All right, here it is. I've broken into the secret files of Pythagorean theorems converse, and I found, dun dun dun, the key. It's in some secret file hidden away somewhere. Here's the master computer. Yep, and then down below, of course, we found the key. And here's the inside scoop on Pythagorean theorem and its converse. Well, y'all know Pythagorean theorem. That's no big deal, but there's a big secret to be told. Here's Pythagorean theorem as we know it. 13 squared plus 23 squared equals x squared. You know, leg squared plus leg squared equals hypotenuse squared. If it's a right triangle, and look at that. It's a perfect 90-degree angle. If we go over here to number 2, though, check out this. This is top secret stuff. We've got x squared plus 21 squared. We're missing one of the legs, but we have the hypotenuse. Check this out. X squared plus 21 squared is 34 squared. Now if we go back, we can actually square each of those numbers and then just solve, get x squared by itself. And then finally, you remember how this happens? I haven't seen this in ages. They took the square root of both sides to get down to 26.74. The square root of 715 is 26.74. Who knew? And then check this out. There are 3 huge clues in this particular file we found. And I better get out of here pretty quick before somebody finds me. But we have, in this triangle, it's even embedded, it's like code. This looks like maybe a rhombus or something. And inside I see some sides, but I see a right triangle, and that's the key. There's a right angle. 14 squared plus x squared is 16 squared. And if they get x squared by itself, we just take a square root of both sides and we get x equals 7.75. This is fascinating. But this is what we came for, folks. There's even black markings, secret stuff that we can't even access. Look at that blacked out stuff in here. I don't know what that's all about, but at least we have a few clues to go on. It says that we can determine if a triangle is not just a right triangle, but if it's right, acute, or obtuse by looking at that relationship of the long leg. Hey, the long leg 20, if we square that and compare it to the sum of the squares of the 2 shorter sides, we can tell which kind of triangle it is. Like, if the long side squared is bigger than the sum of the squared of the 2 other sides, it's an obtuse triangle. And that's what we've got right here. Check this out. 400 is greater than 221. That's 100 squared plus 11 squared is 221. 20 squared is 400. It's bigger than the sum of the other squares. It's an obtuse triangle. I don't even have to draw it. Maybe that's what's under here. It's the drawing. Who knows? Over here we have another obtuse triangle. The long side, 49 squared, is bigger than the sum of the 2 smaller, 12 squared plus 14 squared. Here it is. That one's huge. We knew that one. Then there's the acute triangle, that mysterious acute triangle. Here's some weird code too, like radical signs and square roots. So we have the long side is 11. We square that and compare it to the sum of the squares of the 2 shorter sides. 5 times the square root of 2 squared and 10 squared. Why, that's 100. That's 50. That's actually bigger than our little side 121. That's 11 squared. So the long side squared is smaller than the sum of the other 2 sides squared. That means we got an acute triangle. So it's all about the long side squared and seeing if it's less than the sum of the other 2, it's acute. If it's greater than the sum of the other 2, it's obtuse. And if it's equal to, it's a right triangle. In this case, that's what we've got going. Why don't you guys take this top secret information, see if you can crack the rest of the code, take it home with you, bring it back tomorrow.